wise. This will have all the real numbers in between. You understand by real numbers, right? Real numbers are all, for example, pi by 2, pi will also be here. All the numbers which we see, positive numbers, on the right side of the axis. This is called x-axis, this is called y-axis, this is of negative x-axis, and this is negative y-axis. So likewise here it will be -1, -2. This is positive y-axis, so 1, 2, -1, -2. So this is our coordinate axis. Okay, so in coordinate axis, say we start with some point. A point can be anything which can be located in the anywhere in the plane, coordinate geometry plane. So it can have coordinates of x and y. What it means is it is x distance from the origin, and y distance from the x-axis, right? This will be a 90 degree, because we can calculate the distance perpendicular. We will calculate the distance perpendicularly, so it will be y. And it might extend some angle here. Let's say it's called theta. So this is called an angle. So any two line segments, if say we have two line segments, we call this an angle. Angle has two type of units. One is degree, which we all know, and one is radian. We are going to study about radian in a while. So this is a ray, and say this is its vertex. We can call it O. Now with this as vertex, just try to move this arrow a little bit up along the circle. So with same distance, it might form an angle here, right? So if we have traversed this side, that is anti-clockwise, that will be called as positive angle. And say if you go down like your clock, you might have seen in your clock, it goes down like this, right? So when it happens clockwise, we call it as a negative angle. So this is what it has also mentioned in the first like the subchapter of this chapter, where it says something about the angles. So this is called the angle, and then something called initial side and the terminal side. So whatever you have seen, this was the initial side, this was the initial side, and this would be the terminal side, right? So this is with respect to angle. Now let's go to let's see one right angle triangle here. The right angle triangle. Degrees, and say the angle is theta here, right? So let's say it A, call it B and C. What is A, B and C? These are the corresponding length of the sides of the triangle. So we know Pythagoras theorem. Which says c square is equals to b square plus a square. This you might have read previously, which is true for all the right angle triangle. What is a right angle triangle? Which has at least 190 degree. So say if this is theta, what will be this value? Say suppose we name it alpha. Let's find the value of alpha. So alpha, so we know all the sum of the angles of a triangle is how much? 180 degree, right? So 180 degree is equals to alpha degree, which we need to find out, plus theta, which is theta, plus 90 degree. 90 degrees. So if I just transpose it here and transpose it here, so alpha becomes 90 minus theta. So this value is basically 90 minus theta. So we can say in a right angle triangle, So we can say in a right angle triangle that if this is theta, this would be 90 minus theta, and this is 90 degree. Okay, I'll mention the name again. C B and A. C A and B. So we know sine theta is equals to B by C. Now this B by C is just a ratio. We need to remember this, that it is just a ratio. The value of sine B by C is always less than 1. We will see it how. We'll always see it how. But it's a ratio. What is a ratio? Say you might have seen many replicas. For example, you might have seen small replicas of pyramids like this. And then we have the original pyramids. Right? So what you will find, the ratio of this by ratio of this would, and the ratio of this to the ratio of this would be same. For example, if this is 10 and this is 5, so the ratio is how much? 2. So in your replica it will be 4. If this side is 4, then it will be 2. So that's why it's a replica. So this is just a ratio. We need to understand what's a ratio. That's why I'm trying to make you understand what exactly is the ratio, right? So sine theta is B by C. So sine theta is equals to B by C. What is cos theta? Cos theta is equals to E by C. And what is tan theta? Tan theta is equals to sine theta by cos theta. Right? So there's one more learning here. Sine theta is also equal to 1 by cosec theta. Cos theta is also equal to 1 by sec theta. And this is tan theta, sorry. Tan theta. And tan theta is equals to 1 by cot theta. That's all. There is no complications in this. It's just a inverse. So jotting down again, we have. So if I have to know what is cosec theta, so the cosec theta would be C by B, the inverse, the inverse of this thing. Sec theta would be C by A. Sec theta would be C by A, and cot theta would be just the inverse. So sin theta by cos theta. Sin theta by cos theta is how much? C will cancel, so it will be B by A, which is also perpendicular by base. So sin theta, tan theta equal to B by A, so cot theta would be A by B. Right? So I just said a few minutes back that the ratio is always less than 1 sin theta. Let's see what I mean by this. So say we have this triangle theta, C, B and A. So we know A square plus B square is equals to C square. We also know sin theta is equals to B by C, cos theta is equals to E by C. Now we know from our previous classes that a hypotenuse of any right angle triangle is the largest side of the triangle. That means C would be greater than B, and also C is greater than A. Right? Means whatever the value. So for example, let's say one right angle triangle. One famous example is this one: 5, 4 and 3. So 3 square plus 4 square is equals to 5 square, which is 9 plus 16. 9 is equals to 25, right? So 3, 4, 5 is one Pythagorean triplet. Now, so here you will see that 5 is greater than 4 and 5 is also greater than 3. So that is what I am writing here. So C is greater than B and C is also greater than A. So now from here we will find B is equals to C sin theta and A is equals to C cos of theta. Now replace this here. So C would be greater than B. What is B? C sin theta. And what is A? C cos theta. So that means C is greater than C cos of theta. Now if you cancel C from this equation from both the sides, we will find that it becomes 1. So that means we will always see that sin theta is less than 1 and cos theta is less than 1. See, this is the proof why sin theta and cos theta is less than 1. So always remember, whatever the value of theta would be, sin theta and cos theta would be always less than 1. The maximum value of cos theta and the maximum value of sin theta would be 1. So say in a graph, if this is 1 from 0, so whatever the graph of cos theta sin theta would be, which we will see later, that should not cross 1, which is 0, 1. I hope this is clear. So we have established cos theta is less than 1, sin theta is less than 1. Okay, always. Here I would like to mention is this is just an introduction to the inequalities. Inequality is one of the important chapters we will come across. The original range of cos and sin theta is like this. They both have the range of 1 and -1. That means it can be equal to -1 but not less than -1, and it can be equal to 1 but not greater than 1. Same thing with the sin theta. We will see the same thing in the in our text as well. So this we will cover going we will be covering in this next video, this part, which is basically your domain and range of trigonometric functions, where it is mentioned this, and also we will be we will also see the sign of trigonometric functions going further. So we also know, so from here, from this triangle, we also know a square plus b square equal to c square. Now if I replace this a with b here, so for example, if I take this if I take this equation again, a square plus b square is equals to c square. Now if I replace a with what? C cos theta, and b with c sin theta. So a, if I replace with c cos theta, it becomes what? C cos theta whole square plus b. What is b? C sin theta. C sin theta whole square is equals to how much? C square, which is here. Let's move ahead with this equation. So it will be how much? What it will be? C square cos square theta plus c square sin square theta, which should be equal to how much? C square. Cancel c square from both the sides. If you cancel c square from both the sides, so c square, c square, c square. So we get cos square theta plus sin square theta is equals to 1. So let's see what we have established so far. We know theta, and this is 90, and we saw previously that this angle will be how much? 90 minus theta, right? So this is A, this is B, and this is C, are the length of the respective sides of this right angle triangle. So sin theta is how much? A by C. Cos theta is how much? B by C. Now if I take this angle into consideration, so for this angle the perpendicular will be B, So for this triangle, sine 90 minus theta, would be equal to how much? So for this angle, perpendicular by hypotenuse, which is B by C, equal to B by C. And cos of 90 minus theta would be, A by C, because this would be the base. If we consider this angle, this would be the base. A by C is equals to A by C. Now here see, from this observation, you are seeing B by C is equals to cos theta and A by C is equal to sin theta. So let me replace this B by C. B by C is equals to how much? Cos theta, and A by C is how much? Sin theta. I can also say that means sin 90 minus theta is equals to cos theta, and cos 90 minus theta is equals to sin theta. Okay, let's not forget this. So we have added one thing here more. So in here, if I have to add, we have also learned that cos 90 minus theta is equals to sin theta, and sin 90 minus theta is equals to cos theta. Clear, right? So now, moving ahead, let's go back to the chapter. So now we have covered degree. Now let's cover radian. So now we know what is degree, right? We know that one complete revolution will make a 360 degree angle, and 1 by 360th of that revolution is called 1 degree. So what it means is, say we have one, so if I make a complete rotation, the angle it will cover will be how much? 360. This you might have learned from the previous class also. 360 degree from here. So what will be half of 360? 180 degree, where it will reach half circle. So say for example, if I traverse from, if this is center of a circle, if I start, and this is the radius, this is O, center of the circle, and I'm here. Now say if I start traversing here, and when I make a complete circle, I finish 360 degree. So if I divide it by 2, which is 180 degree, by the time it is 180 degree, where will I reach? I will reach on the opposite side, exactly, diametrically opposite side from where I started. So this will be like a semicircle, right? So I started from here, and this angle would be how much? 180 degrees. So we know when complete revolution has been done, we call it 360 degree. So I can say one revolution somewhere corresponds to 360 degree. Then what will be 1 degree? 1 by 360th of the revolution. You bring it down. So basically what I'm trying to say is 1 revolution corresponds to 360 degree. So if I divide it by 360 in the both sides, so that means 1/36th of a revolution would be equal to, correspond to 1 degree, right? So that is what it is trying to tell you here as well. And then it is further divided into minutes and seconds. So as you can see here, so if we have turned completely one round, it is 360 degree. If it is only halfway, 180 degree. Again, if you add 90 degree to this, you will reach 270 degree. And likewise, what is 420 degree? You would have finished 360 first, and after that 360 minus 420 minus 360 would be 60 degree. So basically it returns, it is only 60 degree from your x-axis. If we have gone this direction, then it will be a negative. It will have a negative value, as it says here. We have so far used degrees, that it is 30 degrees or 40 degrees, 50 degrees, something like that. That's what we have used. From now on, we should be able to use, we should be replacing this degree with the use of radian. So an angle can be measured in degrees and radian. What is a radian? Let's see what is a radian first. What is a radian? So say we have a circle. Of radius r. R units. R units is, it can be 100 meters. It can be 0.1 centimeter. It can be pi kilometers. You understand? Any units. Let's say some distance. It is some distance from, say, the length of your arm. Length of your arm. Say it is, I don't know, 1.2 meters. So say r. And from here, you start from here, and along the arc of this circle, you move exactly 1.2 meters, which is the value of r. Right? From here, you have started moving along the arc and you have covered exactly 1.2 meters, which is the value of r here. So from center, if I join this point, there will be an angle here. So angle. There will be an angle here. So this angle is called 1 radian. That means what is 1 radian? If I have to ask, what is 1 radian? So it is the angle subtended by the arc of the same length of the radius. So we have radius r, we have traversed r distance from any point starting. So say we have started from here, and if we have traversed r distance here also, so this angle and this angle would be same. That will be equal to 1 radian. That is the definition of 1 radian. Previously we have seen the definition of 1 degree, right? 1 degree, which was 1/360th of a revolution. So what is 1 radian? 1 radian is the angle subtended by the arc from where it has started and covered the same distance of the radius. That is our 1 radian. So what a generic definition would be, so that was 1 radian, right? So a generic definition of radian would be, say this is r, and you have not covered exactly r, you have covered some different distance, say l, and this is theta. So by definition, theta radian would be equal to L by R. Is it clear? So that's what it is written here also. Theta equal to L by R. Right? So that was with the radians. Now let's see one more catch up with the radians. So say for example, as I said, when in a circle of radius r, if you have covered r distance, how much radian it is? It is 1 radian. I'll put it like this: 1 radian. Correct. This is what we have learned so far. Now, if I have to traverse a complete circle from here, complete circle, and come back to the same point, how many radians I would have done? So let's find out. So for example, for covering r distance, that corresponds to how much? 1 radian. Right? For r distance, we are covering in the arc. Okay. What will happen when I cover the whole circle? So the whole circle, when I cover, how much distance I would have covered? That is equal to the circumference of the circle. Circumference of the circle, which is equals to how much? 2 pi r. Right? So for example, if I extend it here again, so 2 pi r, that means a complete circle when I have finished. It's a complete circle, right? It's a complete circle I have traversed. I would have finished how many radians? 2 pi radians. I've just multiplied it by 2 pi, both the sides. So if I multiply it by 2 pi, this becomes a complete circle, and this becomes 2 pi radians. That means when I have because the complete revolution of a circle, that corresponds to 2 pi radians, right? And we know previously that this also equals to 360 degrees. So we can say 2 pi radians is equals to 360 degrees, or pi radian is equals to 180 degree. Okay. This is clear? So interchangeably we use pi as 180 degree, pi as 180 degree. So what will be pi by 2? 90 degree. What will be 2 pi? 360 degrees. This is how we interchangeably use. Okay. This is what corresponds to pi. So I hope all this is clear. You can go back to the video again if you want for your reference. So this is how interchangeably we use. And this is how pi is related to your radians. So for example, so I would say if pi radian is equals to 180 degrees, then how much is 1 radian? 1 radian is would be equal to 180 by pi degrees. Right? And 1 degree would be how much? I have just transposed it to here, right? So this, I think you should know this. A by C equals to B by D. I can always interchange, so that will also become D by B equal to C by A, AD equal to BC, likewise. So I'll be using this pretty often in the video, so it should not confuse you. So for example, what I have done here is pi radian equal to 180 degree, and then 1 radian would be equal to 180. Similarly, 1 degree would be equal to how much? 1 degree would be equal to how much? Pi by 180 radian. Right? So this is what your relationship with degree and radian. We have done the introduction, of course, and then we studied about the angles also. What is the initial side, terminal side? We saw the degree measurement, the details of what is a degree and what is a radian. We also saw that how radians is related to degree as well. So here the way it was for degrees, if it goes anti-clockwise, it will be positive degree. It will be positive angle, and for radian also. So if it moves in an anti-clockwise direction, it will be a positive radian, and if it moves in a clockwise direction, it will be a negative radian, as you can see here. So there is one circle where they have a radius of 1. In our case it was r, we considered as r. It has considered 1 here. So if it goes anti-clockwise, if it goes in a clockwise direction, then this would be a negative radian, right? So let's move to the next topic, which is the relation between the radian and the real numbers. So let's see what it says here. Consider a unit circle with center O. Okay, let A be a point on the circle. Let A be a point on the circle. O is the initial side of the circle, and there will be a measure of the circle. Consider PQ, which is the tangent of the circle A. Okay, so this is a circle with center O, and this is a tangent at point A. Line PAQ, which is circle at point A, represent real number 0. Okay, so this is 0, this is 1, this is 2, this is -1, and this is 2. It says if we rope the line AP in the anti-clockwise direction, rope the line AP. So for example, if we put a center here and this is the rope, and if we move it in the anti-clockwise direction, so okay, so at some point it will touch here. Okay, then every real number will correspond to the radian measure. Conversely, radian measures or real numbers can be considered as ones. And okay, so what it is trying to say here is basically it is trying to put a relationship between radian measures and the real numbers. So it says that radian measures are actually real numbers. This we saw previously also. We were seeing here that while we were traversing across this thing, right, across the arc, we can use any real numbers here. So let's see what it says specifically in this part. It says what does it mean here when let A point. Let's visualize what it's saying here. So what it says here is, say there is one circle, okay, it's center O, and there is a point. Okay, let me redraw it properly. Say we have a circle here, okay, say we have a circle here. So now it says that there is a tangent to this circle, which is a point A here. This is point A, and this is the center of the circle, which is O. Now so in the real number 9, this will be -1 and -2. Just imagine this, just do not just consider these two as a different separate entities. Consider this circle differently and consider this blue coordinates differently. We are just measuring the sides of the, we are just measuring the circle. Okay, so it has name O, A, P and Q. Okay, so it has given this name as P, and this is as Q. So what it says is, now we have a line, say we have a we have a y-axis which corresponds to positive real numbers and the negative real numbers here, and it is a tangent at point A here. This is the point A to a circle with some radius, say R. Okay, so what they are trying to tell you here is, if we rope the line AP in the anti-clockwise direction of the circle, so what is the rope line? AP here, so AP is this line. So they are saying this line, this particular line, say if we try to, with this as a as center, so what they are saying is, say this is a circle, this is the point A, and this is P, this is the center O. What it says is, say with respect to this, you move it clockwise, anti-clockwise, so like this, 1, 2. So there will be a point when this one will be projected at here, and this will be corresponding to 1 unit, right? In the same way, on the other side, -1 and -2, if with this as a vertex, so here with this as a vertex A, and this is Q and 0, and this is -1 and -2. So it will also project it somewhere here. This distance will be -1, this arc. So what it says is, this will extend a negative angle, negative radian, and this will extend a positive radian, and this radians, whatever it is, whatever the value is, those are coming from the real numbers. These are the real numbers. That is what it means here, that radian measure and real numbers can be considered as the same. Okay, so that's up to here. Let's move into the next thing, relationship between degree and radian, that we have already seen. 1 pi equal to 180 by pi radians and all. This also we have seen. Notational convention, like we use pi as 180 degree, that also we have seen. And this is your standard formula. So if someone asks you convert 6 radians into degree measure, what do you do? This is your mantra. You start with this formula. As soon as you see degree and radian, you write this formula: pi radian equal to 180. From there you start, multiply, divide, whatever it takes. So it is 6 radians. So if pi radians equal to 186 radians equal to, it does the calculation, and how it comes. So let's move into the next point, which is the trigonometric functions. This function we have already established, right? Sin square x plus cos square x, sin square x plus cos square x. So we need to know that in any triangle, cos square x plus sin square x equal to 1. We have seen this thing. And it says that a square plus cos square, since one complete rotation subtends an angle of 2 pi. So when you have completed one circle directly, completely, you would have finished 360 degrees, which is also equal to 2 pi, right? So AOB, it says, is 90 degree. Okay, so this is 90 degree, and AOC is pi. Okay, so after of every 90 multiples of every 90 degrees is called quadrantal angles. Don't worry, this will never be asked in your competitive examinations or anywhere. And now it establishes the value of sine of all the values of all the angles, like sine 90, sine 60, likewise. So let's establish, let's establish some formulas here. So for example, we'll try to find the values of all the degrees. So for example, we have 0 degree. So let's say we'll consider these degrees. This is theta degree, 0, 30, 45, 60, 90, 180 and 360. Okay, so in theta radian, how much it will happen? 0 will be 0, 30 would be how much? 180 by pi by 6. This, let's say 45 only. This is pi by 3, this is pi by 2, this is pi, and this is how much? 2 pi. Yeah. Let's see. So let's first of all, let's try to find, we are going to find the value of sine and cos of all the above values. We'll see how to derive it, so that you should not have any problem going further deriving yourself. So let's find out these values. Let's start with 0 degree. What is 0 degree? What happens? What is the value of sine 0? That means we are trying to find the value of sine 0 and cos 0. So let's see. Let's say we have a triangle, and we have an angle theta here. This is C, this is A, this is B, and we know sine theta is equals to B by C. We are trying to find the value of sine theta when theta is equals to 0. That means it says when theta is equals to 0, what will be the value of sine theta, right? So when will this theta become 0? So say in this triangle, we have this triangle, say this is 30 degree, say let's start, this is some 10 degree, okay, the same triangle. Okay. In next second you decrease it by 1 degree here. Again after that you decrease it by 1 degree. A time will come when this will completely merge with this space, right? When this space merges, this will completely diminish, this side will completely gone. Okay, let me explain it better. Say you have a triangle here, okay, and this is your C, A and B. Okay, so say it extends an angle of theta here. So now what happens? Sine theta is equals to B by C. Clear? Say this example, let's say theta can be any value, right? Any value. So let's say it is 9 degrees. So we have a rectangle where a theta is 9 degree and a length C, B and A. Now in the next second what you do is you decrease this angle by 1 degree more. So what will happen is now this line will shift somewhere here in 9 degree. After that you decrease it by 1 degree more, 8 degree. So it will come here, right? At one point of time what will happen is after 1 degree, when you move it to 0 degree, it will actually merge with this line, this baseline. So when this above line merges with the baseline, then this reduces to 0, this completely diminishes, right? How? So for example, whatever we had in 9 degree, after when we have moved to 8 degree, this height has come down. Whatever, suppose it had a distance of x, say it was a distance of B previously, it would have been less than B if we would have decreased the angle by 1 degree. After that, if we would have decreased the angle by 1 degree less more, 1 degree less, then this B would have decreased further, right? So this B is going down as we decrease the angle. So a point will come when this angle is 0 and the b will become 0, and when b will become 0, this sine 0 will become 0. So that means when we have 0, sine 0 will be equal to 0, because there is no height as well, because there is no height in the triangle. So that is sine theta equal to 0. We have learned previously what? Cos 90 minus theta equal to sine theta, right? So if I replace theta by 0, I can say cos 90 is equals to sine 0. That means cos 90 equal to 0, right? So we have covered two things here: cos 0, sine 0, and cos 90, which is pi by 2, right? So this is with respect to 0 degree. So sine 0 is 0. Say this is your triangle, this is your equilateral triangle, right? So here I'm going to drop a perpendicular from here till here. So perpendicular, and this distance is how much? X. So since this is an equilateral triangle, this will be also x. So if this is 60, because of an equilateral triangle, this is 60, what will be this angle? So by rule of 90 degree also, 90 degrees 90, 60, so this will be 30 degrees, and this would be how much? 30 degrees. Also, this is a perpendicular bisector as well of this line. So from center, if it is coming from the vertices of a vertex of a equilateral triangle, it will bisect it, it will equally bisect it, it will make it 30 30 from 60. So now let's consider this height, this height as h. I will consider this height as h. This height, okay. This height of from where? From A, B, and this is C, and this would be D. So here what will happen is, I'm saying AD is equals to H. We know AC is equals to X. We also know AB is equals to X. We also know BC is equals to X, right? What will be DC? So BD and DC would be same, because it's a perpendicular bisector. That will become x by 2, correct? Now consider the triangle ABD. Consider this triangle A, B and D. So if I take this triangle, here, this is a triangle. This is x, this is x by 2, and this is how much? H. This would be x by 2. This will also be x by 2. H, right? And then we have 60 degree here, and this is 30 degree here, correct? So we know from Pythagoras theorem that x square would be equal to how much? H square plus x by 2 whole square, right? X square would be equal to the perpendicular plus base square. So x square would be equal to h square plus x square by 2. Now we also know, so consider we are trying to find the value of sine 30, right? So sine 30 is how much? So sine 30 would be equal to x by 2 by x, right? If I consider this angle, so sine 30 would be how much? For this triangle, perpendicular by hypotenuse, that will be x by 2 whole divided by x, right? And cos 30 would be how much? H by x, right? So let's jot it down here. I'll rephrase it better. So we have a triangle. So we have a triangle here. We have a triangle here, which is, this is 60 degree, this is 30 degree, this is x by 2, this is x, and this is h. And sine 30 is how much? Sine 30 for this triangle equal to x by 2 divided by x. If I cancel it, so sine 30 will be equal to half, right? So since sine 30 is equals to how much? Cos 90 minus 30, that is cos 60. So that means sine 30 equal to cos 30 equal to half. Let's try to find the value of sine 30 now, sine 60 now. So what will be sine 60 from here? Sine 60 will be h by x. X square is equals to h square plus x by 2 whole square from Pythagoras theorem. So that means, let's replace, we are trying to find the value of sine 60, right? So let's replace h by x sine 60. We take it here and replace it in this equation. So what will happen here is x square would be equals to h square. H is x sine 60 ka whole square plus x square by 4. Am I correct? X by 2 whole square equal to x square by 4. This will become how much? X square is equals to x square sine square 60 plus x square by 4. I divide by x square from both the side. This will become, so that means 1 is equals to sine square 60 plus 1 by 4, or I can say sine square 60 is equals to 1 minus 1 by 4, which is equals to 3 by 4. That means sine 60 would be equal to plus minus root 3 by 2, right? So since we are taking only the distance here, it's in first quadrant only, so we will take it, so the value of sine 60 will be root 3 by 2, root 3 by 2, right? So if sine 60 is root 3 by 2, what will be cos 30, which will be equal to root 3 by 2 as well. So here you can see these values they have established here. Okay, they have not established here. This is how it will look like. So now if I have to ask you what is sine 90, what will you say? What is the value of sine 90? So sine 90 is also equal to sine pi by 2, right? Which is shown here, sine pi by 2. Sine pi by 2. It says sine pi by 2 is equals to 1. How? So we have seen cos 0 is equals to 1, we know. So cos 0 is also equal to how much? Sine 90 minus 0. So if sine 90 minus 0 is equals to how much? Sine 90. So sine 90 is equals to how much? Cos 0 is equals to 1. Sine 90 will be equal to 1. So that means sine pi by 2 equal to 1, which is being shown here as well. Right? So I hope this is clear. Cos x we have already discussed. Now we have shown that for all real x, sin square x plus cos square equal to 1. It follows that 1 plus tan square x equal to x square x and 1 plus cot square equals to y. So let's see y. So you know, sin square x plus cos square x is equals to 1. Now I divide both the sides by sin square theta. So I divide this by sin square theta, sin square x, this divide by sin square x, and this divide by sin square x. Sin square x by sin square x by sin square is equals to how much? 1 plus cos by sin. Cos by sin is sin by cos is tan, cos by sin is cot. So that will be cot square theta is equals to, what is 1 by sine? Cosec. It will be cosec square theta. Cosec square theta, as it shows here. 1 plus cot square theta is equal to cosec square theta. If you divide it by cos square theta, then you will get the other value. So which will be, so if you have sine square theta plus cos square theta is equals to 1, you divide it by, and now we want to derive which one? We want to divide tan. So we'll divide by cos square x in both the side. Cos square theta, cos square theta, cos square theta. This becomes how much? Tan square theta plus this is how much? Cos square theta, cos square theta 1 is equals to 1 by cos square theta. What is 1 by cos square theta? Sec theta. So it will become sec square theta. So 1 by tan square theta equal to 1 plus sin square theta. So that's what we have established here as well.